All right, the graph of y equals cosine x is transformed to the graph of that. Find a sequence of simple geometric transformations that does this. Okay, so it's a vertical shift up 8. It is a reflection about so negative y, so x-axis. It's a vertical stretch by 2, and it's a horizontal stretch or shrink. So we are dividing by pi over 6. So it's a stretch, scale factor pi over 6. And I wrote these out of order because I would do this first and then these two at the same time. I would just multiply the y's by -2 and then this one. All right, number 25. The graph represents that. We have to find that stuff. Okay, so max is 2, min is -4. So C is max plus min over 2. So that's going to be -1, and it looks like it. And then A is max minus min over 2. So that's 3. This is a sine function. So this point here, because it's been moved down 1, and then it's also been shifted. Okay, so it's fine because like it's a +3 because it's going up from that kind of origin that's been transformed. All right, so let's see this max here, because we don't know this point, okay? But we know this max is usually at pi over 2, right? That's when sine is the greatest. So if it's moved from pi over 2 to 3 pi over 4, you can find that horizontal transformation, which is pi over 4. Okay, so B should be pi over 4. But it should be negative because it's moving to the right. So like this, remember it's the opposite inside the brackets. Okay, 26. We've got this, write down the range of the function f. Well, it's going from -4 to 2. Write down the number of solutions for x equals -2. So it's 1, 2, 3, 4. And write down the values of k for which the function f at x equals k for -2 pi to 2 pi has exactly 2 solutions. Okay, so that is happening -4. Or k equals 2, because also up here there's 2 solutions. Everywhere in between, like here, is having more than. All right, now for double I, we have exactly 4 solutions. So this one, 1, 2, 3, 4, because that one's not equal. That works. Below, so that's for k equals -3 here. 1, 2, 3, 4, that's fine. So basically here as well, but not down here because that's 2. So we have k has to be in between, so not equal to -4. and then up to -3 is fine. Here, 1, 2, 3, 4, that's fine. 1, 2, 3, 4, all the way up to 2 as well. Okay, and then has no solution. So this is outside. So k less than -4 or k greater than 2. Because outside of that, it's not intersecting the function at all. All right, we've got this function for the depth of water in meters, t hours after midnight. Find the maximum depth and minimum depth of the water. So we've got the principal axis is 8 and amplitude's 4. So we go from 8 up 4, that's 12, that's the max depth, and 8 minus 4 is the min depth. All right, find the values of t for which h at t is greater than or equal to 8. So I used the graphing calculator and I changed the x's in the window settings, menu 4. I changed that to -2 to 26 because our domain is 0 to 24, so I went a little bit outside of that. And then I knew the maximum depth, so I went from 0 to 16. And now we just need to find, and then this red line is 8. So it's the values of t for which the functions above 8 is going to be here. So we need to find from here to here, and then from here to here, and then from here. So we need to find all 5 intersections, and that's the answer. So this first one is from 0 to 8. The second one is from 12 to, it should be 20, because these are, you know, the periodic functions. So it's going to have the same no, but it doesn't. Oh my gosh. Okay, this one's wrong. This is 6. I looked at the y. Okay, so this is 6. This is 18. And then the last one, is going to be, so that's at 24. So we don't actually, so, and t equals 24. But nothing after that because that's not part of our domain. All right, 28, we've got the sine function. The graph of y intercepts the x-axis at point A. Find the coordinate from 0 to pi. So we need to find when y is 0. Okay? So this is from 0 to pi. So we need to subtract, because we need we need plus pi over 9. So we're at 0 plus pi over 9, and then pi plus pi over 9 is 10 pi over 9. So when is sine 0? Well, it's no longer here because that's not part of our thing. Here, yes. And then this is just 1 1/9 pi, so that's the only place. So we just now have to subtract pi over 9, so 8 pi over 9 should be the answer. Yeah, I'm not doing that. If you're doing that, then graph this and find the x-intercepts. That's what you're doing. Make sure they're in between 0 and pi. All right, solve the equation. Okay, so again, our domain is going to change, and we now have 2 pi plus pi over 9, so that's 19 pi over 9. And when is sine -1/2? That's at, oh, wrong one. That's pi over 6. Okay, so we're here and here, pi over 6, because sine is negative. So we're going to have x plus pi over 9 equals, so pi plus pi over 6 is 7 pi over 6. And then we're at 11 pi over 6. And these with denominator 9. So this is 18, 21 pi, and 18, 33 pi, and 18, 2 pi. So we're going to have that 21 pi over 18 minus 2 pi, that's 19 pi over 18. And then 33, 31 pi over 18. All right, we've got 29, a tangent. So this is with graphing calculator. Okay, so this is how you put it in. Remember, you need the tangent and the brackets, square that whole thing. I changed my domain from negative pi over 3 to pi over 3, and we have to, it's going by pi over 9. We're dividing that into thirds. And then I don't know why I did up to 15. Sorry, up to 5, but it should be to 15 on the y max. All right, so when you're graphing these things, you need to figure out what the y is that you need to graph it from negative pi over 3 to pi over 3. So do graph trace and do pi over 3, which is going to be 8.54. So like here, and then you need negative pi over 3. Negative pi over 3. And that's at 15.5. Pi over negative 15.5. You need x and y intercepts now, okay? So we can do analyze graph 0 for the x-intercept, which is 0, 0, and 0.666. All right, which is happening like here. Not 0, 0. Y-intercept is 0 as well, and then you just need the minimum. So all the features that are important. So that's 0.381. Hold on, stuff's in the way. So it's a little bit after pi over 9 and negative. So like here. So that's the point, 0.381 negative 0.846. And then you can definitely get other points there if you don't feel comfortable, but that's how it looks. So now solve the equation f at x equals 1. I'm going to tab, put in 1, and I'm going to find those intersections. Okay, so one of them is x is 0, negative 0.207, and the other one, analyze graph, intersection, is 0.772. 30, we've got that and that. The graph is shown. There's a max at that. Write down the value of b. So this is the f function. We have, well, we can just do f at 0.5, which is 1/2, so 6 sine pi over 2. This is just 6. On the same diagram, sketch the graph of g. So you just need to put it in the function, the graphing calculator. Oh yeah, and then also the max is obviously 6 because of the amplitude, and the principal axis is 0, so either way. Okay, so for b, I just put this on the graphing calculator, and you've got to find the y-intercept, which is through the trace function. So 0. Oh no, sorry. So you have to push the up button. So 0, 3. Maybe like here. And then we need the x-intercept of the red function, or the e function, which is 0.693. And there is no, max or min of this. And we need the endpoint. So we need trace to 2, which is negative 2.19. Sorry. 2, negative 2.19. And then we just need the intersections of these functions, because also C is saying that too. So the first one is at 0.125 in 2.30. The next one is at 1.05 and negative 0.896. And the last one, like here, is, 1 second, 1.89, negative 2.09. Okay, so just something like that, whatever. So now for C, you need where f equals g from 0.5 to 1.5. This one is not counting because it's before 0.5. This one works, and this one does not work because it's outside of the domain. 31. So describe the sequence of transformations from sine to f. Okay. So first of all, if you write it like this, it's going to be a horizontal shrink, scale factor 3. All right, so we're dividing all the x's by 3. Then we have horizontal shift to the right, 1/3. Then we have vertical stretch, scale factor 2. Solve the inequality. So for this one, we have to graph it. Okay, so this is our graph, and we want to know when sine is bigger than the parabola. Okay, so this right here, sine is bigger than the parabola, and this sine is bigger than the parabola. Everywhere else it's smaller. So we need to find those intersections. So from negative 1.36 to negative 0.832, or 0.354 to 1.14. That's when sine's greater than the parabola. And these are like this. I think they're usually like this. I don't really like doing that because they're rounded, but whatever. 32, by observing the graph of the function that, write down the range, number of solutions to 0, and the exact period. So we got to graph this. Okay, so this is the function. We need to find the max and the min. like the most min. And we need, so the range is going from negative 1.78 to 2.41. And write down the number of solutions to 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 maybe. I would see, because I did it a little bit outside. So you got to see, I think that is exactly 2 pi. So 13 it should be. Except it's not 0 or 2 pi, so it's 11. Now write down the exact period of the function f. So within this, we've got 1, 2, 3 things, 3 cycles. So it should be 2 pi over 3. All right, consider the functions f and g. Find the period of f of g. So we have, this is e to the 2 sine pi over 2x. Okay, graph it. So if we find like this point and this point, we can find the period if they're nice numbers, and they end up being, so it's 1, this is 1, and this is 5, so the period is 4. Find the intervals for which f of g is greater than 4, so we need to put in 4. So we want, so if this is 4, we want here and here, so we need all 4 of those intersections. So we've got from 0.488 to 1.51. That's from here to here. And then we've got from 4.49 to 5.51. And in the mark scheme, they just do this one, and then they add 4 to each. So you can do it that way too.